Hello everyone. Welcome to the Stats for the Masses webinar, Overview of Research Designs. My name is Elaine Eisenbeisz. I am the owner and principal statistician here at Omega Statistics. We originally had this webinar live, a live broadcast on July 24th, but due to technical difficulties, the audio did not come out well, so we're re-recording it. So today it's just me. Heather's not here with me, and so I will be handling this and answering questions that we did receive during the live event at the end of the webinar. There are about 3 or 4 of them. So I guess we'll just get started. Today I'm going to present an overview of research designs. There are many types of research questions one may ask. Almost as many designs to help us find information and conclusions that we can think of. There are just so many of them. Today is just an overview, but I hope that the information you receive today will give you a way of looking at design, not just in terms of a null and an alternative hypothesis or in terms of bits and pieces of the process, but holistically. All the parts fit together, and I'm hoping that you'll see that maybe by the end of this webinar. The presentation should last about 30 minutes, 30 to 40 minutes. Then I'm going to take some time to answer the questions we did receive at the live event. Let's go ahead and get started. This slide tells you a little bit about Omega Statistics. I'd like just to go through really quick and just to explain to you what we're trying to accomplish with our Stats for the Masses webinars, seminars, newsletters. Statistics can be difficult. It's a difficult subject for even seasoned researchers. So often textbooks, classes, training programs, they can make things even more confusing. My goal with the Stats for the Masses series and for Omega Statistics as a company is to inform and educate about statistical concepts in the most layman's terms we can. Sometimes that's not easy, but we're trying to do our best, and I would just like to make it so that everyone can see the elegance and usefulness of statistics. We do have another webinar coming up in September. It'll be September 25th. It's entitled Power Analysis, a Brief Yet Useful Overview. Webinars are always free and recorded, so if you can't make it live to the live meeting, then you view it later. Get the webinar, register for it, view it later at your convenience. A little bit about Omega Statistics. We are a private practice statistical consultancy based in Southern California. We do all kinds of research. We help all kinds of researchers in many, many different fields. Medical and clinical research, we do assist with clinical trials, phases 1 through 4. Design and analysis of experiments, large epidemiology studies, and other large data, journal article assistance. If you're a researcher, you're trying to get your study written so you can maybe publish it in a journal, and that's usually the end goal. We're there to help you with that, with your methods and your results sections in order to do that. And we do help with exploratory design, predictive modeling. Dissertation assistance is a big thing that we do. We do help with the methods and results chapters. We design surveys. We take on projects of almost any size, small, large, individual researchers, small businesses, startups, large corporations, government contracts. Our motto is elegant solutions effectively applied, and I do my best to provide that type of service. So I guess the big question is, what is research design? And if you look at a textbook, you might find that it is the specific process a researcher uses to collect, analyze, and interpret data. The Stats for the Masses definition of research design is that it's your recipe for your research. What are you making? What are your ingredients? How are you going to cook and serve it? Will it be tasty? Is it going to be informative? Is it going to, expand the literature base? It's always important. The best studies have repeatability and generalizability. Now, repeatability, the specifications of the design are laid out in a way that another researcher could take that information, design, and implement the study in the exact same way you did. Generalizability means that not only will the results apply to the population you sampled for your study, But when your study design is repeated with another population, the results should be similar. Repeatability and generalizability give more validity and impact to the results of a study. Now, we can usually design a study for repeatability. We just make sure our methods are really, concrete, operationalized and such. But generalizability, it's a bit harder to come by. And it usually only happens by repeating the study over and over, or by using randomized sampling or a random sampling. And we'll cover more on the randomized and random sampling later. There are three very broad classifications of research design. There are descriptive designs. It describes the subject or the phenomena of study with words or numbers or both. There are correlational designs. They measure the relationship or association between variables. And then there are experimental designs. And in experimental design, the researcher manipulates the subjects or phenomena of study to investigate cause and effect relationships. In essence, if I do this to one group but not to the others, which would be your cause, does it change the outcome, which would be your effect, is the outcome. For today's webinar, we're going to use a very simple study. For our study, we want to understand the relationship between the sunrise and crowing roosters. First step would be, what's my research question? Depending on the type of design, your research question is going to sound a little bit different. Research question defines all of the next steps in the study also. So you define that, and that kind of gives you the direction of where you're going. If you have a descriptive design, your question might be, why does a rooster crow at sunrise? You'll find in descriptive designs that the research questions are very esoteric. Why is this? Why does this happen? What is the meaning of this? So descriptive designs can be quite fun. Correlational design is you're looking at associations. So your question could be, is there an association between the sun rising and roosters crowing? And you often see words like association or relationship with a correlational design. Experimental design has your cause and effect. So you might ask, does the sunrise cause the roosters to crow? The cause would be the sun rising. The effect would be roosters crowing. Step 2, maybe even more important than step 1. How exactly will I answer my research question? I always suggest that you start your literature review before you begin outlining your design. It's always good to know, have others asked a similar question, or have they focused on a similar concept or theory? What kind of instruments are out there? What have people used before? Is there an instrument you can use? Populations, so what population was used? Maybe your population is a little bit different, which would be great. Maybe it's similar, and there might be a study you can replicate. What sample sizes have been used? What type of analyses? What kind of statistical tests were used in the similar studies? These are all good things to know, and they'll inform your decision on what you want to do. What kind of information can I get? That would be your third step. You kind of have an idea, you've seen what's out there, you've kind of seen what other people have done. Well, how are you going to collect your information? You have a research question, now you need to, how are you going to operationalize that? What kind of information are you going to get? Is the data I need already collected and available? If you need to collect the data, how are you going to do it? Sometimes there are instruments or tools available. Sometimes you might need to develop your own tool. My suggestion would be not to develop your own tool unless you absolutely must do so. If you need to develop a survey, you can. However, if there's one that's out there that's been used before in a similar type of study, maybe with a different population than yours, but it will help you with your study and work with your population, always see if you can use that. You can ask a researcher that has developed the instrument. You can always email or call the author, get permission. They usually love to have you use your instruments in your research, and all you really need to do is provide a citation that you've used your instruments. Sometimes there are proprietary instruments and you need to pay a fee, but there are so many survey tools and other types of instruments out there that are free, and they're just there for the asking. So always try to check on that. Otherwise, if you design your own instrument, it can be done. Sometimes you have to do it. Sometimes there's not something out there that you can find or that you can use. And if you do need to design your own instrument, you can. It's just there's a lot that you need to do. Establish validity, reliability, pilot test it. You need to test it to make sure that it's answering the questions you want. It's just a lot more time and effort involved. So if it's out there and you can use it and you get permission, do that. Step 4 would be to develop your statistical hypotheses, and this is kind of where people will start running into their walls, because sometimes they can be a little bit confusing. The statistical hypotheses are the statements you make to test your research question. They're worded to fit the tools you'll be using in your design, and they're also worded to fit the process of the scientific method that that in general that you are using. There's two types, there's two research hypotheses. There's actually two hypotheses you need. You will need the null hypothesis, which is no effect. This is a hypothesis that states there's no difference, no relationship, nothing special happening here, nothing going on. And then there's the alternative hypothesis. And this is the statement that matches what you want your study to show. It's usually what you're asking. The confusing thing is that we'll draw our conclusions based on the null and not on the alternative hypothesis. And we'll discuss that a little bit more later. So for descriptive research, let's start with that. You'll have research questions, and usually you don't have hypotheses because you're not really testing anything. You're observing. You're asking the why. You're questioning, but you're not really testing something. However, there are quantitative and qualitative types of descriptive designs. In a quantitative design, type of study would be a naturalistic observational study. A researcher could ask, what proportion of roosters crow at sunrise? So she visits a farm each morning at sunrise. She notes the rooster's actions and crowing habits. Perhaps she notes the time each rooster crows and how long each rooster crows. And maybe she describes the weather conditions at the time. That might be important. It might be something to know. There are qualitative types of descriptive designs also. There's many types of qualitative studies, too many to cover today. But in general, a qualitative study is an observational study with the goal of obtaining a deeper understanding of a phenomenon. A researcher asks, why does a rooster crow at sunrise? She can't interview roosters, but she asks a group of chicken farmers 10 open-ended questions about their thoughts. And then she will build her study around that. In a correlational design, you do now have your research questions and your statistical hypotheses because you're going to be testing things. Correlational research questions usually have the words relationship or association in them. Sometimes predict will be used if the correlational design involves a regression. The research question in a correlational design would be, is there an association between the sun rising and roosters crowing? So your null hypothesis would be there's not a statistically significant correlation between the sun rising and roosters crowing. There you have it's not not. The alternative hypothesis is there is a statistically significant correlation between the sun rising and roosters crowing. Now the researcher is then going to measure if the sun rises each day. And she's going to code it 1 for yes and 0 for cloudy, rainy, foggy, any other condition where the sun doesn't rise and shine. The researcher also measures if the roosters crow within a 5-minute time interval after the scheduled sunrise. And she's going to use the farmer's almanac to see when the sunrise is. And then she's going to use that to tell her. That's her tool that she's going to use, maybe her instrumentation. She's going to code it 1 for yes and 0 for no if they crow. The researcher then performs a correlational analysis. In this case, it would be a feed correlation because both of the variable responses are dichotomous. They're yes or no, 1 for yes, 0 for no. It's the same exact calculation as a Pearson's correlation. You might have heard of that. So sometimes statisticians have to call the same thing 5 different names. So anyway, mathematically it's the same. The researcher finds a strong and direct correlation between the sunrise and roosters crowing. Therefore, she concludes that there's an association between the two variables. But here's where you need to be careful because you have to remember that correlation does not imply causation. Okay, the sun and rooster correlational study would be a great way to understand this concept. Correlation was strong. Let's say it was strong and direct. Okay, it was 0.8. A correlation of 1 would be perfect, but that would mean that every time the sun rose, the roosters crowed, that rooster crowed. So it would be perfect. The p-value we'll say is 0.025, so you have that nice significance. It's less than 0.05 if you have the 95% confidence interval. So it's a great correlational association. It's nice, it's direct, it's showing that, there's an association between that sun rising and that the roosters crowing, and everyone knows that the sunrise is related to rooster crowing, right? But however, the roosters crowing did not cause the sun to rise. Okay, so therefore, correlation does not imply causation. Okay, so you can't say that the roosters made that sun come up. However, everyone knows that the sunrise does cause a rooster to crow. So knowing that, kind of assuming that, we could try an experimental study to kind of show that. So how does one show what we already know in this case, that the sun does cause roosters to crow? The experimental design is what we would use. It's the gold standard of research design. It is the only type of design in which one can claim cause and effect. And experimental design has internal validity at its core. And what that means is that if a manipulation is performed, then the outcome happens. And if a manipulation is not performed, then the outcome does not happen. So you can't just show it one way. You want to see both ways to get that internal validity. Now the outcome, it could be anything. It could be an improvement or a change in health. It could be an improvement in test scores, a change in appetite, any other measurable factor observed when a treatment or intervention is performed on one group but not on another group. Now you can have more than two groups. We're only going to use two for our example with the roosters and the sun. However, there are many times you'll have more than two groups. Many clinical trials in a pharmaceutical industry, maybe you're testing a new drug and you're going to have 4 groups. Maybe you'll have a 5 milligram group, a 10 milligram group, a 20 milligram group, and a placebo. So you're going to have 4 groups. You're doing an intervention or you're giving that drug to 3 groups but not the one. So everything else you're going to try to keep as similar as possible. The age, the genders, whatever you have, you want each group to be as similar as possible, and you only want the thing that you're doing, the intervention, the one thing you're doing to the groups to be the only thing that's really different between them. And that's the caveat. The groups must be as similar as possible prior to the treatment or the intervention. This similarity is called homogeneity. And it is accomplished by establishing inclusion and exclusion criteria, and even more so, random sampling or randomization into the treatment groups will really help you to establish that homogeneity. The research question in your experimental design could be, does the sunrise cause roosters to crow? So hypothesis would be there's not a statistically significant difference, excuse me, in crowing frequency between roosters who see the sunrise and roosters who do not see the sunrise. The alternative hypothesis could be that there is a statistically significant difference in crowing frequency, between the 2 groups of roosters. Your inclusion criteria, you want male chickens because they need to be roosters. Probably want them over the age of 1. Because that means they're not little peeps anymore. They're not babies anymore, so they're going to be crowing. We want them to have good eyesight because we want them to be able to see that sunrise. And we would like them to have a demonstrated ability to crow. You don't want roosters that don't like to crow or don't crow or not able to for some reason. An exclusion criteria could be female chickens. You don't want any, not hens, you only want roosters. You don't want little babies. You don't want little peeps. So we don't want chickens that are less than a year of age, and we don't want roosters who cannot see well. The inclusion and exclusion criteria are important to all research designs, not just experimental designs, all research designs. They define the population from which you're going to pull your sample. You need to be specific sometimes. You just can't go out and go, oh, okay, for everybody in the world, I'm going to do this study. You want to make it specific. It doesn't make sense to put little peeps and hens into a rooster study. The researcher recruits the roosters who meet the eligibility criteria from various farms located in the area. Now this is going to be randomized. She's not randomly sampling. She's not doing the random sampling before where she's gotten the whole population of roosters and then has gone out and maybe sampled randomly from all of them. In this study, it might be easier to have the roosters come to her. So as each rooster comes into the study, they're randomized into one of two groups. They're either going to the intervention or the control. And the intervention group is going to be that during the evening, the roosters are going to be placed into a pen with an opening on the top to allow the sun to shine through. Okay, so they'll see it in the morning. The control group is during the evening, the roosters are going to be placed into a pen without an opening on the top, so no sun's going to shine through. Now, except for the pen assignment in the evening, the roosters will be free to go about their day in a communal area. They're going to eat the same food, exercise the same amount, get the same type of social interaction. Now, the researcher could have exerted much, much more control in the study and just placed one group of roosters in the sunny pen and the other group in the dark pen 24 hours a day, and maybe fed them the same amount of food through a little hole in the side of the pen or something. But she's kind. And she doesn't want to harm the animals. She just wants to study them. So she's going to be ethical and allow them to hang out during the day. Each morning, the researcher notes the number of roosters who crowed in each of the two groups during the 10 minutes after sunrise, as she computed from her farmer's almanac. Okay. Now, she might have some researcher assistants help her, so she has some checks into place. So maybe she has some extra people watching, like 2 people on one pen and 2 people watching the other pen. She might, maybe she wants to audio tape the crowing in each pen just to make sure she's counted them all. Okay. After 1 month, she's compared the number of crows that were emitted at sunrise for each of the 2 groups, and she compares the findings. And she determines that the roosters that saw the sunrise crowed significantly more than the roosters who did not see the sunrise. Now let's revisit that generalizability and repeatability. Since her design was randomized and controlled, she could potentially generalize her findings to similar types of roosters that did not come from the farms that she collected her sample from. Okay, so she can generalize it to a larger group of roosters. Study must be randomized in order to even attempt to claim generalizability. That's important to understand. Generalizability, though, even though you randomize it, it might not be so easy. What if the researcher only used one breed of rooster? So could the findings be different if she sampled from farms in another part of the world, or had different breeds of roosters? Maybe they're different. So this is where the repeatability will come in handy. It's important to make sure you cover all the bases you can, therefore, in the methods of your design, and that's where the methods come in. So after you decide what kind of design you're going to use, then it's time to start getting into the nuts and bolts of it, into the methods. The methods are the roadmap of repeatability. You operationalize your variables. That means what kind of variables are you getting? What type of, if you're using an instrument, how are you going to score your variables? How are you going to code your variables? You need to know all this. You want to get all those little pieces in order. You want to determine what kind of analyses you're going to use. What kind of statistical tests are going to answer my question? How am I going to measure these outcomes? And always have a backup plan, just in case your sampling, your data collection and such doesn't go as planned. You never know. You might plan for a t-test, and there are certain assumptions you will need to make to use a t-test. And you need normality, you need equal variances, you don't want a lot of outliers. So you might pull a sample where you have no normality, you have outliers all over the place, and most importantly, probably the most important assumption to make, assumption is another name for a requirement, is that you have equal variances, and you might not. You don't know until you pull your sample. Something could happen where you don't. And so you want to have a backup plan. So maybe you would say that if I can't use my t-test, I'm going to have a backup, a non-parametric technique, maybe a Mann-Whitney U-test. And that way all you have to worry about is that you can rank the data, which is great. You don't have to worry about the normality anymore, or equal variances even. So it's always good to have that backup plan. Think about possible control variables. Okay, the big 5 for many studies are age, gender, race, socioeconomic status, and marital status. Of course, for this study, we don't have to worry about many of these variables. Of course, roosters might have other control criteria, such as age or breed. They won't have marital status, things like that. But studies are all about time and money when it comes down to it. How much time do you have, and how much money can you spend? Because you can look at all kinds of variables, but how important are they? How much time do you have to get all that information? How much money do you have to spend on the study. There's always limitations. So you want to make sure that you choose wisely about how you're setting it up and how you're putting everything together. There are numerous methods available for collecting data and crunching numbers, and there's too many to cover in a 1 hour webinar. And methods aren't really designed. I mean, the methods of sampling analysis are interchangeable too between quantitative studies. There is a difference. Methods are basically how you're going to do the design, how you're actually going to do everything. The design, though, is kind of your overview. Is going to be, what you're doing. The methods will be mostly the ingredients, right? You have your recipe, but then you have the actual ingredients. Some references to learn some more I have listed here. The USC Libraries has a great paper about organizing research, and it shows many of the different kinds of research designs that are available, and there's probably more than they cover, but I think it's about a 2 or 3 page paper. It just doesn't go over the 3 that we covered here today, but there's quasi-experimental, there's case studies, there's all kinds of designs. So you're not just stuck with 3. The 3 actually will have subgroups. So look at that, and that'll give you some more ideas. It even tells you what it does show, what it doesn't show, what it's good for, what it's not so good for, limitations on them. So it's a very, very good paper. There's also a paper it's about experimental designs, and it's from the statistics department at Yale. And it covers a lot of the things we did today for the experimental designs. And if you really want to dig deep into the theory and intricacies of research design, an author wrote a paper on a website that's hosted by NYU, and it's a little bit heavier than maybe many people would want on the statistics end of it, on the theory end of it. However, I do enjoy the way this author did think about the difference between design and methods. So if I was still a little ambiguous to you on the difference between design and methods, read that paper, gloss over the things that you don't quite get, but you'll get the gist of the difference. I think it's very informative. There are a couple good books. I love these people. Tabachnik and Fidel, 2 great ladies. They really know how to put statistics in a nice, easy-to-read format, easy-to-understand format. These are 2 of their books that are very good. The first one is Experimental Design Using ANOVA. Many, many experimental studies do make use of ANOVA, factorial designs. They're all related to an ANOVA. Even a regression is related to an ANOVA. And then if you want to know some more about different methods, a good one is Using Multivariate Statistics. They're great authors, or great ladies. I think they used to be belly dancers years and years and years ago and put themselves through school. So they're just very interesting. And I'd like to thank you for attending. And for those of you who did attend the live webinar, thank you for that. Thank you for your patience with us. And I do hope to see everybody in September at our power analysis seminar. So I had a couple questions, so I'm just going to go over them. These are a couple questions that the people asked that did attend the live event. So I'll just get started on those. How important is it to have a random sample? That's the first question. Well, it depends. If you want that generalizability, it's very important. It's not always possible to do a study with a random sample or to randomize. It's just, if you have an observational study, then you just want to see how it's really happening. You kind of want to get a good grasp of the real time, real life kind of thing. So you're not going to do any kind of manipulation. You're just looking at it. So it really depends on your study. But if you want that generalizability and you want to say that something you're doing, some kind of intervention has an effect, then it is very important. So it depends. It depends on your design. Okay, and it depends on your study. The next question that we had was, how big of a sample do I need? And what is a sufficiently large sample? That's a big question. If you ask a professor, if you've ever taken a stats class, and they always talk about sufficiently large, your sample must be sufficiently large, and everybody asks, well, what's sufficiently large? And the professor will say, it depends. And that's the big answer to the big question, is it depends. And it does depend. It depends on the type of test you're using. You can use a t-test. You can get away with a sample of 30. If you use regression, depending on the number of variables you have, a rule of thumb is 20 20 records for each variable, each predictor variable. Some people say 10. So it also depends on who you're reading. It also, so the important thing is to do that literature review. You cite the whatever ones you're using. If you decide to go with the 10, cite that one. It really depends. I mean, you can do a structural equation model and you want 500 records, but then there are some people that say, oh, you can get away with 250. So it depends on who you read. It depends on what's been done before. It also depends on the power of your study, and that's a big thing we're going to be covering in September with the power analysis. It's going to be about trying to determine the optimal sample size, because you can get one that's too big, and you can also get one that's too small. And you certainly don't want one that's too small, because you won't have enough power to see significance that's in the data, even if it's really there. If you don't have enough power, the significance could be there staring you in the face, but you won't see it. So the effect, the size of the effect you're looking for has a lot to do with the sample that you're going to pull. Again, that comes back to the power analysis. So, come September, it's free. Come watch that, But in the meantime, you have your literature to look at, maybe some similar studies, but it does have a lot to do. It does depend. It depends on the test you're using, the type of design you're using. There's a lot that matters on the size of a sample. But it's not impossible to figure out. It can be done. The next question would be, what is the difference between research methods and research design? It's a very good question. As I said, the design is like, it's your recipe, right? The methods are your ingredients. So that's probably the best way I could say it. But your design, you can have a lot of different types of methods that go with certain designs. But the design is basically what you're setting up to try to set up your hypotheses and such. That type of part of it is your design. The methods is what instruments am I going to use? How am I going to collect my sample? How am I going to score things? What type of analyses am I going to use? What kind of statistical tests? Those are your methods. So it's basically your methods are the actual ingredients, the nuts and bolts of it. Design is more the overarching kind of thing that you're looking at. Am I going to set it up to what kind of question am I asking? It has to do with the question, the type of questions you're asking. The methods are the ingredients or the actual things you're putting in to answer those questions. And that's probably the best way I can say it. The last one, the last question that we had was, can I have more than one design in my study? And what if I have more than one research question? Well, actually, it's two questions, right? So, yes, you can have more than one design. You certainly can. There are mixed method studies where you might have a correlational design. Maybe you're doing a regression. You've given people a survey, and you're putting in things like controls like ethnic group, gender, and you're looking at the outcome of a survey. Maybe you have two surveys. You're looking at the outcome of emotional intelligence on job satisfaction, right? So you have that correlational kind of design. And then you might also pull some people out of the group, 10 people or so, 5 volunteers, 10 volunteers, to answer maybe 10 questions, open-ended questions. What do you think about your job? How happy are you? What could be changed? Get a little more in-depth. So there you have your descriptive with your open-ended questions, and then you have your correlational design. So it is always possible to have more than one design in a study. It's also very often you'll have more than one research question. There are many studies that have more than one research question, and that's allowed. You don't have to limit yourself. However, you don't want to make it so that it just becomes very, very cumbersome. So you want to be as specific as you can and cover what you can. So that's why it's nice to think about your design and the methods you're going to use. Once you get through that, you'll have your roadmap. You just have to go out there and get that data and run your numbers, right? So that's what I have for today, and I'm glad that so many of you are interested in these webinars, and we're hoping to keep presenting these. Please email me if you have any questions about anything, if there's something you'd like us to cover, if you have any more questions about this webinar today. I am available by phone or email, but it's probably best to get in touch with me by email. I'll always answer those. Phone, we're very, very busy, so email is probably the best way to go. But I love to talk stats, and I would just love to hear more, about what you think and where your questions are coming from. That'll inform me for future webinars. So again, thank you very much for coming, and I hope to see you all in September. Okay, alrighty, thank you.